Reciprocal functions. We've done a lot of transformations this year. Our first unit was transformations, and then throughout the year we've done some special transformations. For example, one of the special transformations we did and we learned how to do was, if you have any function, how do you graph the square root of any function? And that's where 0 and 1 stayed the same, and when your y values were between 0 and 1 it was slightly above, and after 1 it was below. And that was one of the special transformations that we did. Another special transformation that we're going to do is the 1 over f of x graph. And the 1 over f of x graph says you could have any graph whatsoever on the bottom. What does our new graph look like? And you did this in grade 11 with parabolas and lines. And so some of the ideas that we're going to see today, you've already seen. But now we're going to do it with any function on the bottom. A note here that 1 over f of x is not the inverse function. It's not the same as f to the negative 1 of x. Even though you can do exponents that way, in function notation, they mean two different things. Now, what I have here is some steps that we're going to go through for graphing reciprocal graphs. If I wanted to make today's lesson really, really short, this is what it would be. When you have a 1 over f of x graph, all that you do is you take any point on f of x, and all that changes is the y value changes to 1 over y. That's the lesson. And then you would have to go out and figure out what happens with that and try to graph ones. But if you know that every point, the y value just changes to 1 over y, that is the reciprocal graph. It's the same thing when we did our square root graphs. Any point on f of x, all that you did was square root the y value. Right? If you had the point 2, 4, you would square root the 4 and it becomes 2, 2. So we've seen this idea before with other special graphs. But with the 1 over f of x graph, there's some interesting things that happen. So it's not just enough to say, change your y values to 1 over y and you're good to go. So we're going to look at some steps here. And I think I've got 5 or 6 steps listed. I'm going to reduce those to like 3 for you so that it's even easier to remember how to do. We're always going to draw f of x first. That's the first thing that we're going to do. And then the second thing we're going to do is look at asymptotes. If you have an x-intercept on your original graph, for example 3, 0, and the only rule is that y value changes to 1 over y, then that point is going to change to 1 over 0. What's the problem with that? Can't divide by 0. And so what we're going to have is an asymptote wherever our original graph has an x-intercept. And with these steps, I'm going to go through them rather quickly on the steps. Then we'll see an example which really shows what I mean by all of these steps. And then we can go back to the steps and think about them some more, which I think will really make you be able to understand it really well. So we're going to have vertical asymptotes wherever we have x-intercepts. And we're going to have horizontal asymptotes if your original graph either goes up forever or down forever. In other words, the y values either get to be very big positive numbers or very big negative numbers. If we think about it, if we take a value with a very big y value, and then you do the reciprocal, what happens to that very big value? It comes very, very close to 0. And the bigger your y value gets, the closer to 0 it will get. And so for reciprocal graphs where you have a 1 over f of x, if your graph goes up forever, if there's arrows like an x squared graph goes up forever, or it goes down forever, like a negative x squared graph that points down forever, then you will always have an asymptote, and that asymptote will be at y equals 0. Step 4 and 5, I'm going to relabel as nice points. And nice points are just any point that you can find on your original graph. Now, some points don't change, and they're called invariant points. If I had 3, 1, it would change to 3, 1 over 1, which stays 3, 1. And if I had 5, negative 1, it would change to 5, 1 over negative 1. And then that one wouldn't change either. So some nice points end up not changing whatsoever. And other nice points, so if you had a point 3, 6, it's going to change to 3, 1 over 6. And this is the big idea at the beginning. I said, if I wanted to teach this lesson in 30 seconds, that's it. You just take your y value and change it to 1 over y. And you do that with a bunch of nice points, and you'll get your graph. The tricky part happens with what happens if you have 1 over 0. And that's where the asymptotes come in. And if you have something that, in this step 5, it says, if you have something that's a maximum in a section, then when you do the reciprocal, it's going to become a minimum in that section. Big values become small, small values become big. And finally, you'll have your asymptotes, you'll have a bunch of nice points, and then you can draw your graph towards the asymptotes. Maybe we want to put a note here. A 1 over f of x graph has no x-intercepts. Remember, how do you find an x-intercept? You'd make y equals 0. And the only time a fraction is equal to 0 is if the numerator is equal to 0. And since we have a 1 in the numerator, in this situation, you will never have an x-intercept. So what we're going to do, this examples that I've printed out for you, the graphs that are shown are showing what you would do step by step. So if later on you wanted to go back and see, well, what do I do first, second, third, and follow the steps, this is what's there. What I'm going to do when we work together through this is show you what you would do on a test, how you would set this up. And I came up in the other class with a nice acronym that I really like. So what you're going to do is you're going to draw your first graph, your graph on the bottom first. So we have x squared minus 4. 1, 2, 3, 4. That's a parabola shifted down 4 units. So I'm going to label that point. Maybe I'll label my x-intercepts 2, 0. Negative 2, 0. We're going to label some other points on that graph as well a little bit later. But we'll graph your original function, the function on the bottom, first. And then the steps that I find are really easy to remember. Instead of having to remember 6 steps, you can do steps 2 and 3 together if you just think about asymptotes. Do your asymptotes first. Then steps 4 and 5 you can do together. If you think about nice points. And finally, we'll draw the graph showing the asymptotic behavior. So if you have a friend named Anna, and you're like, I can't remember how to graph reciprocal graphs, you just have to say, well, what would Anna do? And then that maybe can help you remember, do my asymptotes first, then my nice points, then draw my asymptotic behavior. So what does this look like? I've graphed my original function. I do my, right beside here, I'm going to do my asymptotes first. I have vertical asymptotes wherever I had x-intercepts. So I have an x-intercept at 2, an x-intercept at -2. Wow. There we go. And I'll label those. To find out if you have a horizontal asymptote, you have to ask yourself, do the y values get bigger and bigger and bigger? Does it go up to positive infinity for my y values or down to negative infinity for my y values? In my original parabola, yes. Can you see that your y values just keep getting bigger and bigger and bigger? So you will have an asymptote at y equals 0. Nice points. Well, I have 0, -4. That's going to be 0, 1 over -4. What are some other points I could label on here? What happens when x is 1? What do I get? And again, you can always find points by just plugging them in, table of values. What's 1 squared minus 4? 1, -3. Up here you'd have 3, 5. You'd have -1, -3, and -3, 5. So it's quite easy to get a bunch of nice points. Where do those points go? 1, -3 changes to 1 over -3. -1, -3 changes to -1, 1 over -3. 3, 5 changes to 3, 1 over 5. -3, 5 changes to -3, 1 over -5. And once we've done all of these nice points, we have enough information to draw our graph. Because we can draw the asymptotic behavior. You know these have to go down because if it went up, you would have an x-intercept, and reciprocal graphs, 1 over f of x graphs, have no x-intercepts. And in these sections, you can show the asymptotic behavior as well. So you did these graphs last year. Maybe you even gave them a name. Do you remember what you called these? Sad clowns. I don't know, you remember that? Some people, I think it's only our school that made up these names. So, kind of looks like a sad face. Question? Oh, yes, thank you. Should be 1 over, 1 over positive 5. So we did our asymptotes first, did a bunch of nice points, and then you drew your asymptotic behavior. So let's look at the second example. Same thing. We're going to start by graphing the bottom function, which is x squared plus 1. So this is what you would do. X squared plus 1 is a parabola going up. Has a vertex at 1. If you want to label a bunch of points, you've got 1, 2, 2, 5, -1, 2, -2, 5. Thank you. right beside here, we'll draw the reciprocal graph. So first, what would Anna do? Asymptotes. We'll have vertical asymptotes wherever we have x-intercepts. Do we have any x-intercepts? No. No vertical asymptotes. We'll have a horizontal asymptote if our graph goes up forever or if our graph goes down forever. Does that happen? Yes. So we can draw our horizontal asymptote at y equals 0. Next, we can look at nice points. Well, we have 0, 1. What happens to 0, 1? It becomes 1 over 1, which stays the same. What happens to 1, 2? It changes to 1, 1 over 2, and 2, 5 changes to 2, 1 over 5. Same thing on the other side. We'd have negative 1, 1 over 2, and negative 2, 1 over 5. If you take those points and draw the asymptotic behavior, and this is another graph that you saw last year. You remember what you called this one? Speed bump. And if it was underneath, something more common in Winnipeg? Pothole. Excellent. So these first two have been a review. You did these ones last year. We start by drawing our asymptotes. We do our nice points and do the reciprocals of those nice points. That's the big idea of the reciprocal graph, that all that's happening is your y values are changing to 1 over y. And then you draw your graphs towards the asymptote. What makes these graphs hard is they look nothing like the graph that you started with, right? Sometimes a parabola changes into a sad clown, sometimes into a pothole, sometimes into a speed bump, sometimes into a volcano, right? These are all crazy different names that we've given for the shapes of these graphs, but the steps are the same. So now we can look at what would happen to a new graph that we didn't do in grade 11. So what would happen if you graph 1 over the square root of x plus 4? Well, you start off by drawing the bottom function, which is the square root of x plus 4. Using our transformations, that's a square root graph moved 4 to the left. So I go 1, 2, 3, 4. I have the point negative 4, 0. I would have negative 3, 1, 0, 2. The next nice point, 5, 3. Then right next to it, we can start with our asymptotes. Do we have any x-intercepts? Yes, we have one at negative 4. So, at negative 4, we will have a vertical asymptote. Does our graph continue to go up forever? Slowly, but yes. The range of this graph is from 0 to infinity. And so we will also have an asymptote at y equals 0. Next, nice points. What's going to happen to negative 3, 1? It's going to become negative 3, 1 over 1, which stays the same. What's going to happen to 0, 2? It's going to become 0, 1 over 2. And what's going to happen to 5, 3? It's going to change to 5, 1 over 3. So all we're doing is taking the reciprocal of our y values. Now in this section, we have enough to graph. What about in this section? How do we graph what's left of x equals negative 4? We just shake our head and say, what does that mean? Do a checkpoint? Which point would you like to check? Negative 5. What happens when you do negative 5? You get no answer. Because our original graph, nothing exists left of negative 4. Our reciprocal graph, nothing exists left of negative 4. So if your original graph doesn't have anything, your reciprocal graph won't have anything. And this is just like when we added functions or multiplied functions. If something doesn't exist, you can't then put it on. And so you can get any graph on the bottom that you've done in transformations. And finally, what the exam really likes to do is the exam really likes to give you a graph and then say, can you do the reciprocal of the graph that we've given you? So in some ways, I think these questions are even easier because you don't have to do that preliminary step of graphing the function on the bottom. The function on the bottom is already given to you. So right beside it, you can just start by graphing things. Asymptotes. We draw asymptotes when? Whenever we have vertical asymptotes, whenever we have x-intercepts. So we will have a vertical asymptote at negative 1, at negative 2, or positive 2, and at positive 5. So we can label these x equals negative 1, x equals 2, and x equals 5. Does our graph go up forever or down forever? Well, on the left it stops, but on the right there is an arrowhead there indicating that it continues to go up, so we will have an asymptote at y equals 0. If I would learn how to draw straight to begin with, when I add straight lines, they would work out nicer. Nice points. Where do we have nice points? What happens to negative 5, negative 1? It stays negative 5, negative 1. We have negative 2, negative 1. It'll stay at negative 2, negative 1. 0, 1 becomes 0, 1 over 1, which will stay. And 4, negative 1. Will stay at 4, 1 over negative 1. And finally 6, 1. Man, all these points ended up staying. All the nice points that were labeled stayed exactly where they are. How do we draw our asymptotic behavior now? Well, sometimes people wonder, well, I don't know if I just have this one point, do I go up or do I go down? Well, we know that there's no x-intercepts in a 1 over f of x graph. So we know that this section will go up, this section will go down, this section will go here, and this section will go like this. And I made a mistake. So I did it on purpose because it's the most common mistake that people make. And 2 of you noticed it right away because I saw those hands fire up. What did I do wrong? I drew an arrowhead here, right? I have to go back this. All right. Your original graph stopped at -5, -1. So our graph needs to stop at -5, -1. But sometimes with that asymptote there, right, you've been showing asymptotic behavior all morning, and so you feel like you need to keep it drawing that way. But it does stop. Another thing that I find interesting in this is we have a horizontal line here. It ends up being a horizontal line there. And that'll always happen. Even if the horizontal line is at y = 2. When you reciprocate, that's probably not the right word in this, but when you do the reciprocal to all those points, they'll all be at a half. And so you'll get a horizontal line at a half. So horizontal lines stay horizontal lines. So I've got a worksheet for you to practice these.